Today, we are diving into the world of face detection using YOLOv8, one of the powerhouse of object detection. Join me as we explore the fascinating journey of YOLOv8 in spotting faces with precision and speed. Whether you are a seasoned developer or just curious about AI, this tutorial will unravel the secrets behind face detection like never before. If you are excited about this tutorial, kindly give me a thumbs up and also subscribe to the channel, and most importantly, put on the notification bell icon on so that you don't get to miss any of my future goodies. Enough with my self-promotion stuffs, let's get right into it. Finally guys, welcome to the fun part. Let's get our hands dirty and write some code. But before we get started with the code, the files, the code and everything we'll be using in this particular tutorial will be on my GitHub repository, where you can leverage and use it in your own use case. And also, don't worry about installation, because I will include the requirement.txt file where it will include all the packages you need to install in order to follow along. So we are not going to waste time on installing any packages. So the link to the code, the files and everything will be in the YouTube video description. So you just click on the link and it will send you to my GitHub repository where you can download all these files and use. So we first have to download the model we use, the face detection model. The link to this particular repository will also be under the video description where you can download this model. So you have to scroll down, and at the down here we have several face detection model. We have the nano, which is the smallest one, so that means you have more speed when running it, but it's less accurate. We have the medium, you have the large, and we have other models there as well. Our focus in this particular tutorial will be on the nano model. You can explore the other models as well. You can just download them. So you have to just go ahead and click on the nano model and it will get downloaded. So make sure after downloading this model, you place it in the same directory you are writing your code. So I've gone ahead and downloaded this beforehand. All you need is to just click on it. With this step done, we'll head back to our IDE and start to write some code. So you can see I have my model downloaded here and it's in the same directory where I'm working. So I can go ahead now and write some code. So we are going to start with the imports as usual, and with this particular tutorial we'll import OPCV, australities, and finally we'll import CV zone. OPCV for loading in our video feed and also displaying our video feed. CV zone will use it to place some nice text on our video feed, and finally australities, which we use to load our model and do our face detection. With this out of the way, we'll go ahead and specify the path to our video. So I have a video file on my desktop. So here are the videos. So I'll just copy this particular path, paste it here. Don't forget to put R here, and also specify one of the video names. So I'll cross check, and I think one is people.mp4. so I'll just write people.mp4 here. With this, we have successfully loaded the video file we'll be using. I'll also teach you how to use your own webcam to detect your own face. Now let's go ahead and create a video capture object. So we are using cv2.video capture, and in here we can feed in our video file. So in case you don't want to use your video file, then you can specify your camera index. You can start off by putting 0 here, which will pick up your first camera or your camera connected to your computer. If you have many cameras, you can start from 0, 1, 2 and so on. But in this case, you are going to do it on a video file, and we've loaded that video file, so all you need is to specify it here. The next step is go ahead and show this video file. We have done this ton of times in this channel, so I'll just go ahead and show the video file. Alright, so with these few lines of code, we'll be able to show our video file. So I'll go ahead and run it, and let's see what pops up. So you can see here is our video file we'll be using, but straight out from the batch you can see this video file is very big and we need to resize it. So that's what we are going to do next. To resize it, we use the resize function in OPCV. We'll still call this video and we use the cv2.resize. Okay, so we use the resize function. We provided our video and the size we want. Feel free to change this size on your own. So if you don't like the size, you can specify your own height and width here. Let's run it to see our video file in action. Okay, so you can see we have gotten much smaller video size now, and with this now we can work and feed this particular video file into our model for detecting faces. You can't wait for that, right? I know. So let's go ahead. Speaking of detecting faces, we have to go ahead and load our model. So we have to first load the model, then we can feed this particular video file into the model. So I'm going to call this face model. Pardon my choice of variable, and then we'll use the YOLO, and in here we'll specify the name of the model, which is YOLOv8 face, YOLOv8 nano face.pt. so this is it. So we can come down here and now feed this particular video file into the model, and then we are ready for detections. So we will say our face model dot predict, and in here you have to give it the video file, and additionally you can specify the confidence value. So right from the start, I'm going to set this confidence value to 40%. You can modify it as well. So this will return to us our result. So we'll call this face underscore result. So now we can loop over this face result to get our bounding box coordinate on each detected face. So I'll just go ahead and loop over it some number of times and now get those coordinates. Then we can use those coordinates to draw the rectangle on each face detected. Alright guys, so what I've done here is to iterate through the face result, save everything to parameters, and over here we are just getting info.boxes. So this info.boxes will return to us our confidence, our class, which is face in this case, and our bounding box coordinates. But we are only interested in our bounding box coordinates, so we also iterate through our parameters and we use box here to refer. So we get our bounding box coordinate by doing box.xy. We are taking out the first index. So we'll go ahead now and cast this particular coordinate into integer values, because by default they are float values and we can't use float values to draw our bounding box. Okay, so guys, I went ahead and casted all these values into integer values. So the next thing is to draw our bounding box. So you can use the cv2.rectangle method to draw a bounding box, but I found out that using the cv zone to draw a bounding rectangle looks very nice, but for that you need to do some additional tests by getting the width and the height of each bounding box coordinate. So we have to calculate for our height and our width, which is simple by subtracting some coordinates from one another. So we'll start off by subtracting y1 from y2, and for the width we have to do the same thing. So all we have to do now is to go ahead and draw the bounding rectangle on each detected face, and that's the last thing we are going to do. So we'll use cvzone.cornerret, and in here we specify our video. Then the next thing we need to specify here is the coordinates. So it takes this as a list and we'll give it the x1, y1, then finally we give it our width and height. Okay, so these are all you need to specify. You can add some things as the border of the width and all those stuffs. So we can do L equals 9, and RT is also equal to 3. Okay, so that's it. So this is the final thing we need to do. Let's run it now and see how it performs. And here we go guys, you can see it's accurately detecting the faces. This is awesome guys. What do you think? Let me have your opinions in the comment section below. I think this is damn accurate. This is detecting each and every face in the frame. This lady here, or is it a guy, face is not that facing the camera, but it's still detecting it at the sideways. I think this works great. So we'll test this on some couple of videos. We have about 3 videos there. This is the first one. So let's run it on the remaining 2 videos and see how it performs. So we have 10.mp4. Let's see how it performs on that video as well. And boom, here we go, guys. You can see it's performing accurately. It's still detecting the faces. So guys, in my opinion, this model works great, and I think it's a model you can trust. It's a model you can use for your product, your project, and everything, because it's detecting the faces, and I think it's accurate. It's accurate. It's perfect. And bear in mind, this is the nano version of the model. So imagine using the large model, the medium model, you can get more accuracy than this. But in my case, this works great. So finally, we'll load in the last video, and then we'll bring this tutorial to an end. And here we go. This video have a lot of people in it, but you can see the model still do a great job. Some faces are very small here, but it's still working great. So guys, this is it. If you like this tutorial, give me a thumbs up. If you are new, kindly subscribe, and also share this tutorial with someone. Most importantly, put on the notification bell icon so that you don't miss any of my future goodies. As usual, thanks for watching, and I will see you in the next tutorial.